Good evening. We're going to have a session of questions and answers on the webinar we had yesterday. The things we talked about yesterday are the typical maxilla. Just a minute, please. Yeah. Again. Just a second. I just have to get organized in a minute. And then we're going to be okay. Okay, so this is what we talked about yesterday, and I'll just go briefly on the subject we talked about. And I've already received some questions on email, so maybe I'll start with that and we'll start the conversation. But basically, we talked about the typical maxilla that we have. Zygomatic implant trajectories, Zaga classifications, and traditional Brennemark concept versus extramaxillary technique, and the geometrical rules for the zygomatic implantation. And on this, I received some questions. Maybe we can start with that. The orbiter angle, the sinus angle, and the parallel view for collision prevention. So if you have any questions, please write them to me so that I'll be able to answer you. If not, I would just start again, just a little bit to refresh our memory on the geometrical rules. And let me just go briefly, quite fast, to this subject. So it'll take me just a second to get there. Let me see where we are. Just a minute. Oh, no. I'll just go down just a second, please. There we go. Okay, I can start here maybe. This is showing us basically the angles we have for zygomatic implants. So we can have a hybrid implant, okay, position second premolar, aiming towards the zygoma notch. We can have double zygoma, where the anterior implant would be at the area of the canine, and the apex would be as close to something like 5, 7, depends on the anatomy, but as close as possible that we can put it, as close as possible to the orbital rim. We talked yesterday also how this is tricky because not always what we see from here is exactly the distance. Maybe I'll go about over again. And the posterior implant would be something like a second premolar, and aiming towards the zygoma notch without colliding with the anterior implant. Okay, so this is something we'll look at again. And sometimes the implants are colliding when we have a very narrow zygoma. When the distance here is very narrow, we might need to have the implants colliding, one on top of the others in this case. And in this case, we have to make sure that the implants don't touch one another. And maybe we'll talk about this again today. Okay, so let's see what the right angles should be. Just a minute, see, I have some chats here. Let me see. So I have a question here from Boys Averbuch, to all panelists. He's asking, he said he saw the first webinar and the webinar wasn't working, and if he can get the recording. So today we sent to everyone the recording of the webinar. So if you did not get it, please be in touch with our company, with the NAV, or just write me, and I'll make sure that you get it. Okay. So anyway, whatever is written here, we're going to be seeing later on. So we will send you the recording of the webinar. Okay. I have some questions here. Let's see. Okay, from George Wage. Yes, please. I don't know what you're referring, George, but I'll continue. Okay. Anyway, so the question is, what's the angles? Another question. Okay, I'll dismiss the answer. Okay, so the question is, what are the angles to position? So if we look from the outside of the face and we want to place either a one zygoma or two zygomas, what are the angles to put them correctly where we want? That's quite tricky. So there are some rules for that, and I will repeat the rules now. And if maybe it will raise some questions. But first of all, we need to understand and define what is called the orbital angle. Now, when I say what is called, that's the way I call it. There's no really term that I know. I call it an orbital angle, and I'll present what it is. We have to define the implant entry point based on the sinus angle, which is another angle I have defined for this procedure. And then for quad zygoma or double zygoma, when implants are going one on top of the other like that, we need to know how to position the posterior implant without having the apex touch one another. Okay, we don't want the apex touch, we want it to be one on top of the other. And there is a way to see that, a measurable way, no guessing, a measurable way to see that. And I've talked about this yesterday. And this is called the parallel view. And we will understand that what the parallel view is. Okay, so what we see here now, this is, let's say, we want to place one zygoma. Okay, usually it would be, as I said, between let's say the first, second premolar, or maybe even the first molar. Okay, but we want to place one zygoma. When you place one zygoma, we have to make sure that we don't hit the orbit. Okay, so there are boundaries for placing a zygoma. First of all, not to hit the orbit. We need to measure this distance. I call it orbital alert. And there's also, we don't want to fall into temporal fossa. So we need to make sure that we see this area as well. So this angle, the green line, I call it orbital angle. So whenever I use the term orbital angle, you should know that this angle is when the apex of the implant moves up or down, okay, superior, inferior, this way. We have to understand this terminology. Okay. The other angle that is involved is basically the sinus angle, which means how much the implant is going to move posteriorly or anteriorly. Okay. This is the boundaries. If we take the implant in the wrong position, it will be too much to the anterior. It will be perforating the zygoma bone, or if you take it posteriorly, it will fall to the sinus. So I call this a sinus angle. And in order to, once we found the orbital angle, once we found this angle, and we will show how to do that, we actually take a pencil and we mark on the maxillary pencil, not anything else. The only thing that doesn't wipe off is a pencil. So somewhere along this line, there's an entering point And the entering point is this, the point where the center of this implant crosses the bone. It's somewhere here. This would be the entering point for our drilling. At this point, this would be the entering point. And we need to find this entering point. This entering point, the angle, the sinus angle, is defined basically by these 2 points, by the entering point and also by the position the implant is leaning on the crest. Okay, when we make a groove here and we went down to a point on the crest, when the implant or the drill is leaning on this groove here, entering the entering point, basically we are defining now this angle. And we have to know how to define this angle correctly so that we will be at the right position, not fall into the sinus and not be outside of the sinus. I see there are no questions. I'll be very happy to answer questions. So if you do have some questions, just let me know. I'm waiting for them, but I'll just continue fast with this presentation. Okay, so if we are talking about double zygoma, okay, we need to define the orbital angle for the anterior implant. Again, there is orbital alert. There is, in this, now we want to put, because we need to leave enough space for the posterior implant, we need to try to bring the apex of the anterior implant as close as possible to the orbita without perforating the orbita, of course. And we need to check this distance. We also want the apex of the implant to be inside, lower inside. If I go back to the last, we want the apex here to be inside, okay, to leave enough bone for the posterior implant to be above it, okay? And this is in general I'm speaking, okay? It's, we need to remember that. We don't want to, if we put this implant very high, there will not be a possibility to position the posterior implant above it. And the posterior implant will, when they are colliding, the posterior implant will always be above the anterior implant. So if in this case, we need to put it and to leave this possibility to be able to, for us to have the apex above the anterior implant. Okay, so again, the posterior implant, there is, we need to make sure that we don't fall into the temporal fossa, even though it is okay. Sometimes there is no other way rather than going this way because there is no bone. So we can go there, but then we are actually injuring the masseter here, that is anchored here. So when we raise the flap, there is always, we see the fibers of the masseter here. So if there is no other way, then it's done. But if we can avoid that, we can avoid that. Okay. And as I said, in this case, we have a collision alert, and we have to check how to do that. Let me see. I have some questions here. Chats. Let's see what I have in chat. Chats. Hamid Haronian, would you please speak louder? Okay, I will. Hamid, am I speaking loud enough right now? Let me know. Another question about the first lecture from Akil Alexander. I didn't receive the first lecture, so please be in contact, write an email, and you will get it. Even though we sent to all the participants that registered, we sent a copy of the lecture. So either we missed it or you have it in your email. So please check. Roberto, hi, compliments. Do you use some guides to position the implants? Roberto, yes, we do use guides. we have developed a very unique guiding system, which is called Zygoma, and there is a session on the 6th, next Monday. I'm going to have a session on the Zygoma guiding system, and you will see how we do it. And this is answering your question. Okay, I think I covered all the open questions until now. Now I have some other questions. Let's see. Which advantage is realized? This is George Weech. Which advantage is realized to fitting the entry point? Which advantage is related? I don't quite understand the question. Which advantage is related to finding the entry point? Well, I will show in a minute how we find the entry point, but the entry point is, there are two points which are actually leading our implant. One of them, as I said, is the point where the implant is leaning on the crest, and relative to this point is the entry point. And the entry point is crucial to put the implant in the right position. So I hope this answers your question. Which thickness of bone may I expect in which area if I need a strong screwability? If you mean amount of bone for the threaded area of the implants or on the crest, I'll answer both. You need, on the crest, you need to have, excuse me, not on the crest. Let's start with the Zygoma bone. On the Zygoma bone, you need to have bone to anchor the implant in it. Now, if you have a crest which is supporting the implant and enough bone to support the implant for the years to follow without resorption of bone, then you can allow yourself to anchor the implant in the Zygoma bone. Let's say, even if the bone is shorter than if you would have had the need to do that without any crest support. If you don't have a crest support, you need to have a long portion of the implant, let's say at least 15 millimeter of the implant in the Zygoma bone. If you have that, then basically it's a long cantilever and it will hold. And we also have to remember that in a Zygoma implant, it does not work for itself. There is a construction. We have Zygoma implants, we might have other implants involved, we might have pterygoids, but once we have a construction and we put the rigid bar on the construction, it's like building a bridge. I mean a bridge over a river, not a bridge in our mouth. If you take just a piece of paper, the piece of metal that when you put them all together in a construction, they give you the strength of a construction. It's the same thing with the implants. If you take one implant, it will bend. I mean, it's a Zygoma, it might bend, or it might, it's not, it will, you're putting a lot of forces on the bone, but if you close it in construction, it works completely different. When in a construction, there is no torque, there's no moment on the bone, it's only forces, okay? So this is why it's very important to have a very rigid construction. It's the best thing would be to have a splinted bar, not just to put the T-bases in acrylic. It's not strong enough. It's not, maybe for temporaries, but it's not strong enough. The best would be to have a rigid bar. With regard to bicortical stabilization, what if you don't fully exact? If you mean, I'm answering you, Alicia. How are you, Alicia? Let me see something. I want to put you, Alicia. Alicia, I'll let you talk. You want to ask the question again? Alicia?
Yes. Hi. Can you hear me?
Hi.
Hi.
How are you doing?
I'm doing so well. How are you?
I'm great. Okay. What do you mean by your question?
So I get this question a lot, or not a lot, but sometimes from my clinicians that want to keep the anatomy intact, and they don't want to violate the anatomy at the posterior side of the zygoma. So there's a lot of talk about bicortical stabilization from the anterior and the posterior side of the zygoma when we enter, and then when we exit the zygoma. So if the doctor doesn't fully exit or doesn't drill to complete and kind of palpate the posterior side, is it possible to still get cortical, or is it possible to still get cortical stabilization without the drilling through perforating the zygoma?
Okay, so the zygoma bone itself, in the center of the zygoma bone, it's a soft bone. It could be a soft bone. And that's why we want to have a bicortical anchorage. And that's why we want to perforate. When we drill, once we found the angles, the correct angles, what we want to do is actually drill and perforate the other side of the zygoma, where we actually put the finger. The surgeon should put a finger, and he should drill until he feels the implant, the drill perforating the bone, and until he feels the drill in the finger. And the reason for that is that there are two reasons for that. First of all, in this way, we know that we actually use the whole length of the zygoma bone, because if we did not perforate and we don't exactly know where we are, so we might measure, and instead of having 2-3 more millimeters of bone, we are short of that bone, and we are just using an implant. And this comes back to the question I was asked before by George, that the implant will not be long enough in the bone. And this is a shame, because if we could have it, let's say, if we could have it anchored in the longer bone, then it's going to be stronger. So this is one reason why we want to perforate and to make sure that now we can measure the length of the implant to the point that the apex of the implant will come to the cortical bone and will not go further out. It could go a little bit further out, as long as if the surgeon puts the finger and the implant goes, and the surgeon doesn't feel the implant in the finger, you can go further out. Because if you do feel it in the finger, then the patient might feel it when he puts his head on a pillow. Okay, but if you don't feel it, then it's basically okay, and you have bicortical anchorage. I can show. Let me just come. I want to jump very quickly to a slide that I showed yesterday. Let me see that. Let me try to do it quickly. I'll come back later. Just a second. Okay. We see it here. Okay, we see here that we basically, when we come to this position, we have the apex of the implant anchored in a cortical bone. If we did not go all the way through, we wouldn't know the distance. Now we have a measuring tool. Let me just go very fast to this slide, because for some reason I cannot. Let me just see if I can do it faster this way. Just a second. I'm trying to go find the right slide. Yeah, I think we have the right slide. Let's see. Yeah. Share. And you share. do you see the slide? You see? I don't know
Yes.
what you see. You see the slide of the depth probe?
Yes.
Okay, because I can't. Oh yeah. Oh, no. Well, it doesn't work. Let's do it that way. Okay. Basically, when we measure, we want to measure to this point, to the point where we have to this point, the point where we are at the point we perforated the bone. Okay, that's where we want to be. Okay, we can see that. This is the way we want to be, and this is the way to measure and to know what would be the correct implant, because we take the depth probe and we put the depth probe in this position. When we basically put the depth probe out and we hold our finger, we will feel a depth probe in our finger, and then we pull it back, like we pull it back to the position where it's where it stopped on the bone. Okay, and then basically what we do, we are measuring this distance from here to the position we want to have the implant. Okay, so let me just continue where we were. There are some other questions. Let me just come back. It doesn't work properly for me. Okay. Yeah. Okay, we talked about that. I want to come back. Just want to come back to the where I stopped. Where I stopped about the angles. Yeah, we talked about here. Let's see about other questions. Hello, Rami. When you're doing a quad zygoma, which implant do you do first? How do you decide if they are going? This is for Muhammad Ahmed. Okay. How do you How do you decide if they are going to be parallel or overlap with colliding? Okay, this is a very important question. And you know, the surgeons are divided about that. If you do the first implant, the anterior one, or you do the first implant, the posterior one. I will switch to the software, and I will present it on the software. So let me just prepare that a minute, and then maybe it will be clear. Just a second. Okay, I will open the software. I need to open a different one. Just take a few seconds. I'm opening a different software. Okay. So do we all see the software where the maxilla that I'm moving right now? Okay. 1 minute. Participants. Mohammed, I want to put you on speaker. That's why I'm looking for you here. Here, Mohammed. Okay, Mohammed, I'm speaking with you. You hear me? Mohammed, I put you on speaker. Okay, I will answer. Okay. Shit. Okay, what we see here, we see this is the model, but this is not actually a good model for zygomatic implants because there are a lot of bone that we could use for positioning instead of anterior zygomatic implant. But it's a nice model for demonstrating. Now, the question was, what do we want to do first? Do we want to do the anterior implant first or the posterior implant first? So let's say I start with the anterior implant first. Okay, I will take the implant and I'll move it away. Okay, when I look at this implant right now, this implant is positioned. Let me just open here view. I need to change to a mouse. Just a second. Mouse. Okay, I'm putting on a view. A view like that. Okay, that when I look on the right side of the screen, I actually see the view I have here. Okay, if I rotate the view around itself, I see that the picture is on the right side, the section, I see the section moving, okay? If we just go around right now like that, okay, we can see the orbit right now. This is the distance we are from the orbit. You can see it. Basically, this is what we see. This is the distance. And based on this implant, we want to position a posterior implant. Okay, so let's put the posterior implant in place. And yes, I will now come to the to what I've explained yesterday, the parallel view. When I position the posterior implant, okay, if I position the implant this way, okay, now just a second. The implants are very close to one another. You see, they're very, very close to one another. And I can see it from here. I can see it from here. If I will now just hide the maxilla, I see the implants are very, very close to one another. And this is the only view we can see, okay? When we look from this direction, and this direction for us to understand is the direction of, this is the view that we're working. Okay, this is when we look inside, this is the view that we're working in order to position the posterior implant. This is what we do. We look from this area. We look, this is the angle that the surgeon is looking. He is looking at the entrance to the temporal fossa. This is exactly the angle we want to put the posterior implant. But the question is, how do we know if we're actually going to collide with the anterior implant? So we can know that if we move our face until we see the implants from this angle, like that. Okay, like that. And when I see the implants parallel, like that, now they're not parallel. You see, these two lines are not parallel, but the only way when I see them parallel, it's like, imagine that there is a gap of glass between them. One is leaning on top of the glass, one on the bottom of the glass, like that. Okay. And if I see from this view that there is a distance here, that means that there is a distance here. Okay, that's what it means. So I can find the way to do that. Of course, we see now with an implant, but we do that entering point with a diamond. I will show to you later on how we do it with a diamond. We actually have an anterior implant position, and now we need to understand with our diamond that we want to groove how to do it. So I'll show how it's done. But anyway, if we, for instance, did not have the anterior implant, we did not have it, and we started with the posterior one. And when we do the posterior one, we thought the best would be to put it this way. Yeah, we put it this way. Okay. From our entering point, no, this is too much. This is too much. Let's say we put it this way. Okay, like that. Looks fine. We have no of can we or can we not now put an anterior implant because once we have this as a fact, we put an implant. If we come to put an anterior implant right now, let's say we want to put this implant right now, we need to make sure that this implant will not be colliding with the posterior implant. Okay, so let's say we come to this position like that. I need to close that just a minute. We put the implant. We want to put the implant on this trajectory like that. Okay, we want to put it as close to far from the orbit like that, because now we have an orbit here, and we want to put it here. And doesn't work. Just a second. Yeah. Okay, we want to put an implant this way. I'll do it here. It's easier. We want to put an implant here, far from the orbit like that. Okay. In this case, we are lucky because we have enough bone here, and we are not colliding with the posterior implant. But let's say the implant that we did posteriorly first, let's say we put it this way, because we didn't have anything to relate it to. If we did put it this way, then when we come to put the anterior implant, we cannot find a position to put it correctly because we already wasted. We can take the implant towards the orbit like that, and then everything is fine. Okay, but we don't want to do that. We want, first of all, to be in the right secure position near the orbit. And now the posterior implant is actually forcing us to move to a trajectory that we don't want to be in. So this is the reason why, from my point of view, and it's only an engineering point of view, and you know, each one can do what he feels correct for himself. But I would say that doing it this way, we're asking for trouble, rather than if we do it the other way, like I showed. Just look how easy it is. If I had the anterior implant positioned that way, okay, the only thing I need to do right now is bring the posterior implant to position to find the entering point, which I'll show how we do that, okay? And we need to look from this side that we have a gap, and then we're not colliding. That's all. That's all. So we have a relating point that we're not colliding. Okay, I hope I answered this question. This was the answer to Muhammad. George, which advantages is related to, just a minute. Okay, that was, okay. Which advantage is related to finding the entry point? Okay, I will talk about it in a minute. Which thickness of bone may I expect in which area if I need a strong screwability? I'm not sure I follow this question. Let me open and let you speak, George. Just a minute. Let me see. George. Let me see if I can have you here. George. You hear me?
Yes, I can hear you. So just an assumption, Rami, in case I do make this implantation and into this area, and I find out that the implant that I have ordered and that was delivered is too long, is it possible just to cut the screw?
No.
No, it's not possible.
What you need to do when you go into a zygoma surgery, you need to have what we always recommend is, if you go to a quad zygoma, you want to have 4 implants from each length. In this case, you're never going to have a problem unless 3 falls on the floor and you have only 1. Okay. So if you have that, then you will always be safe. But and I showed it yesterday. If you actually, the smallest change, you know, let's go, before we continue here, let's go back to the presentation, which is also, this is also important. Let me go back. No, let me go from here. Just a second. I want to go from here. I think it is here. Let's see if I can do that. Yeah. So it is further. Yeah. So I'll go from the presentation this way, and I'll go down. I'm running very quickly down. I can't do it automatically. I don't know why. I'm not an expert on Zoom yet.
No issue.
Okay. Did you see the presentation yesterday?
No.
Okay, so you missed this. Okay.
Only a part.
Actually, this is the question you're asking right now. When you put the diamond, let's say you decided to put the diamond this way.
Mm-hmm.
This is actually, let's say, okay, for the understanding, this is what you wanted to have. This is what you plan to have. An implant, the green implant, okay?
Yeah.
This green implant has a distance from the, let's say, the tip of the mountain here, okay? When we look from here, okay, when you look from here, this is the angle that you're looking actually, it's like a train coming into a mountain to a tunnel, and there's a train, and you want to go out at a certain point. You don't see from where you're looking, you don't see where you're going to go out. But there, what I call the sinus angle, the sinus angle is actually, this is the sinus angle going up and down here, okay? Would be the distance, when you put a line here parallel to your implant, it will be this distance. And you will see that if you went for some reason to, if the diamond went too low on the same entering point, basically now you're facing this position and the distance is not shorter. Or if you went and if you did not go inside far enough with the diamond, you're way too much into the sinus and you have a bigger length here. Okay, so this length here is the parameter that you can actually measure during surgery to give an indication where you are in terms of the sinus angle. This is the tool, this is the only tool you have to measure that, okay? And
okay.
But look what happens. Oh, I don't have this slide here. Just a second. Basically, if you look at this slide, okay, the distance from here, or the distance from here, or the distance from here, there are different implant lengths. You see? Let's go back here. You see where I'm putting the dot where the green the green implant is now. Look, look where the orange is. Look where the orange is. It's a much shorter implant. Okay, or look at the blue. It's a much longer implant. So this is very gentle. The distance here, what you see here is like 2, 3, 4 degrees to each direction, and you need like plus minus 2.5 or 5 millimeter difference of length of implants.
Rami, I still see the slide with 2 green implants.
Excuse me, what do you mean?
I still see a slide with 2 green implants.
Ah, okay. So
I was just wondering if that's.
No, I've been changing. You don't see the slide changes?
No, I don't see.
Let me see what's. Now do you see?
Yeah.
Now do you see?
The sinus, yeah.
Ah, okay. So I was speaking without. Okay, I'll repeat myself. Okay, so when we have the diamond actually. Let's start from here. The diamond actually describes, makes a groove on the bone to the trajectory we want the implant to go. Let's say this is where we want to be. Okay, this is the green implant is where we want to be. The ability for us to know that this is the right position is the distance here. When you put a parallel line to the diamond, the distance here is giving you the right indication. If you can measure this before the surgery on your software, this distance, and I will show that in a minute, then when you actually make this the groove, you will see this point. Okay, and if you for a reason went with the diamond too deep on the alveolar ridge, when leaving the same entering point, look what happened. So you're much higher, and the distance is shorter. You see, and look at the point where the implant is now. related to the point where the green was before. You see, the green is a much longer implant.
Yeah.
Okay?
Yeah.
And if you went, and if we didn't go further with the diamond enough, like you didn't go on the same entering point, you didn't go further down to the position you were supposed to go, then this distance would be longer, okay? And you have a much longer implant. Maybe it will still hold and everything will be fine and it will be great surgery. But what I'm trying to show you is that you have distance, this different length of implants on the same position with the only small variation of the change of this angle versus the green angle is like 4 degrees. I have a slide for that, but for some reason it doesn't work. Okay, so that's why you need more implants when you come to a surgery. Okay, that's why I need that. I want to go back to the software, and on the software I will be able to show and explain this better. Or maybe no, maybe even on the slide, on the presentation itself. Let me see. I think. Let me just see that. I think if I go up in the presentation, we have it. Okay, we will just talk about it here.
Yeah.
Okay, so let's just talk about it because it's very important. What we see here, this is the line that we found after measurement. I didn't explain how to do that, but if you look at the presentation from yesterday, you will see how it's done. Once we draw this line with a pencil, this will be our line for the orbital angle. That's where we want the implant to be. This is the vector we want it to be. That's how it looks in the isometric. We need to take the diamond, and now we have to guess a point here, an entering point. We want to guess that point because at this point we cannot do it without guessing. Okay, so we want to guess a point, and we put the diamond and we go down to the distance that we know that we need. In this case, we know that we need to come to this distance. We know it in advance. So we come down to this position, and now we measure the height, this height. Okay? That's how we do that. We measure this height. If for some reason we did not go down enough, like we see here, let me go, then we will see a different distance between the measuring device and the diamond. You see the 2 red lines. If we look here, we see a different, this is, you see the line that we went to, the diamond didn't go enough into the alveolar ridge, leaving us a very small line, meaning that we're too low and the implant is not going to the right position. Okay, we can know that. What we need to do in this case would be to take the diamond, either take diamond further down or to move the entering point. But if we took it further down, we might come to a situation like that where we actually are going to be with the implant on the external of the bone. We're going to perforate the bone here, okay? Because we're down. This is why we need to keep this point correctly, as I said before, measured, and move the entering point. And you can see that when you move the entering point, let's say you take it back to this position, then you see the entering point move to this position. Now, actually, you're facing to the correct position, and you can see the right distance that you have measured before, and now you know you are correct. So this is the tool you can use in order to know where to enter. Now let me just take this into the software, and I will just switch the software to a different just a minute. What do you see on the screen right now? Help me. Let me just come back here. I will pause and go to the software just a second. I'm just switching to a software, and the software will show how it's actually done. with the diamond tool. Okay, I'll open this. Okay, let me go to the software right now and new share. And here we go. Okay, so do we all see the software right now?
Yes.
Okay, so I will try to explain what I've just explained to you. Just a second, let me get it set up. Okay. Okay. I will hide what I need to hide right now so that we'll only talk about hiding. Okay. Look at what we have. We have an implant. To understand what what I said before is basically we want to prepare the knowledge graph we need to go on here. Okay, so if you have a software like this, you need to know this dimension. Very important. We can just leave it and just I will use I cannot see this tool here. This I cannot show it. Okay, anyway, I will move the implant right now. Okay, I'll move it away. I'll hide the implant. Okay, so what we see here, this is the line where we want to be. Let's say we guess a point like that. We started guessing a point like that, and actually, yeah, point like that. When I'm saying a point, what we should be looking at when we use when we position an anterior implant, we want to be in a position where we see the zygoma, something like we see it horizontal here. This is the view we want to look at, okay? This is the view. Okay, on this view, I've already pointed where the implant should be, okay? And let's say I guess the point and I come like that, okay? I start from this position and I start going down. You start going down, let's say you came to this position, okay? That's where you are. Now you take the tool, the measuring tool. Let me just take it here. Bring the measuring tool. This is the depth probe from the kit. You put it on the bone from the same angle that we're looking at. Okay, you have to look that you're above. Basically, we want to put the tip, the position you want to measure. Tool. Okay, I put the tip on this position here. I put it here, like that, maybe further in. I just need to lean it on the bone. Let me see why it doesn't work. Yeah, I need to lean it on the bone here. This is where I want to be. Let me put yeah. I want to lean it on the bone here, like that. Okay, and now I want to see. I want it from this angle. I'm here, looking from the side. Okay, looking from the side. I will bring the tool until I'm parallel. You see, I'm bringing the tool until I'm parallel. You see this distance here, and then I'm parallel. And now I have to remember if this is, or measure if this is a distance I wanted or not. And from what we see, this is a very short distance. So we know that actually, if we continue this way, the implant is going to be here, too much outside. That means two things. First of all, we didn't go enough down. For this entering point, we did not go down enough on the ridge. So we continue with moving down on the ridge like that. Let me just do that. we continue going down on the ridge this way. You see? We continue going down to, I'm looking for, to the line where we want it to be, to the distance what we think that we should be. We're still at this position, at this entering point. We did not move the entering point because we made a drill, we made a hole on the bone. So this is our fulcrum. So we went down to this position, and now we take the tool again. And we try to see again if we are okay. What do we see? Even worse, we are much closer. So what do we need to do right now? We know this is the correct position on the crest. So what do we need to do? So what we need to do in this case would be to, let's move the measuring tool, would be to move the entering point to a different position. It has to be somewhere here. Okay, I took it back. This will enable me, and remember that I can do that because over here I already have a groove. I just pulled the drill back and I lean it here. Maybe I don't even make a hole. I lean it here and I take the tool again, like that, and I measure again. Oh, I made a mistake. Just a minute. Mistake. Let's take it back. Yeah. Okay. I'll put the tool again this way, like that. And, yeah. I don't see it because I moved here. Okay. So I have the tool right now. I lean it on the position here. I take it until I see it parallel like that. And now I have the right distance. This is the distance I was expecting. And which means that if I use this, and I'll now put the implant back on, you'll see that we actually found the right trajectory to the implant. So we found the sinus angle to the implant. Okay, look, I'm looking now at the sinus angle. We found the sinus angle to the implant. That's exactly what we wanted to do. So this is a tool that one has to practice until you really know how to work with it. But it is a tool, a measurable tool that can assist this very important measurement. Okay, so now that we've placed the anterior implant, let's move this tool and try to find the posterior. How do we do the posterior implant the same way? How do we, let me just hide those tools. And I'll hide this tool, hide this tool. Okay, so now we have an anterior implant and we want to put the posterior implant. So let's take these tools and do the same thing. I'll move this away. I'll move the, I've already, again, and we have to make sure that we are looking, as I explained before. Let me hide that. It's like we want to look this way. That's how we look. This way we look. We see the temporal fossa here, and that's where we want to go. It's always going to be like that. Okay. And we need to, now what we need to do is first of all to see if you're going to be a crossing. If you're not going to be crossing, the whole thing is different. But if you're going to be crossing, if you're not going to be crossing, so we position the posterior implant with the same method that we position the anterior implant in terms of the sinus angle. It's the same thing. Okay, we will measure it the same way. But if we are crossing, so we will put the diamond. I already marked where the implant was supposed to be. So let's fake a little bit, and I'll move it away. This tool will move away, and I'll move the diamond. Okay, and let's say we decided to come this way. Okay, we lean the diamond on the maxilla. Let's say we started here. Okay, we started here. Put the diamond here, and we grind all the way down. Just a minute. No, before we grind. Okay, we put the diamond here. We come now to this trajectory, to the parallel view. And now we need to analyze, are we going to be colliding? And because we don't see any distance between them, we're actually going to be colliding in this trajectory. We're going to be colliding. What do we want to do? We want to lift the line. We want to lift this line up. We do that by actually taking the diamond. See, when I move the diamond this way, and I rotate my face, you see now I see the distance. That means in this angle, I'm not going to be colliding with the implant. Okay, this line here, you see on the right side, the implants are going to be close, this close, but they're not going to be colliding. So I want to be leaning on the crest. So I will just move the diamond a little bit more, leaning it on the crest like that. Okay, let's say put it on the crest this way. And I see now that for sure I'm not going to be colliding, right? Because I have a distance here, but let's see where I am in terms of the sinus angle. So now I'm going to use this tool actually just to go down, Just a second. Yeah. Okay. I will take the tool, go down this way. What happened to me? Ah, this is the reason it didn't work, because it moved. Okay. Just a minute. Yeah, now it's better. I need to look with the tool exactly at the angle that I want to measure. Okay, so I will take the tool down, look on the right up, and I'll measure the distance here. You see the distance? It's very short. That's not what I want to be. That's not where I want to be. The implant is too far away. That means that in order to have it correctly, I need to take it down. When I take it down, I do it this way. I am in the right angle, and I just go back like that, go back like this here. This would be my entering position right now. Maybe here, like that. Okay. And I will change the angle a little bit more, like that. So I see that I have a distance, so I'm not colliding. I'll take the measuring device, and I'll see what's the distance that I have. This is what I wanted to have. And now, if you look, you'll see that the implant position is correctly. You see, that's where we want the implant to be. This is the distance we want to have. We are not colliding because we have a distance here. And then when I put the implant alive again, we'll see that this is exactly what we planned. So you see, this is a very good tool to let's say expect where we're going to be, where the apex of the implant is going to be. Okay, so this is one of the most important things that that you can take home from this lesson, because it actually gives you the secure way to position a posterior implant. Okay, let's answer some more questions. George, are we good? Or yeah. Okay, Alicia, I see. The library for planning is available in 3Shape Implant Studio, or if it will be. The planning, what we plan on the software you see here. It's our software. It's Norris software. It's called EasyPlan. It's not in the market yet. It's going to be in the market shortly. And today we do the planning for the customers that need our assistance or our guides. This is an answer to Sander Polanco. Demetrios, are you operating always under general anesthesia, or can you place the zygomatic implant under local as well? Well, general anesthesia, it's much better because actually the patient doesn't interfere with what you're doing, and you can do because it is in general anesthesia, it would be quite difficult for the patient this procedure. So let's continue. Alexander Alam, can you discuss the prevalence of failure and complication, please? Any excessive? Just a minute. Well, the question is from Alexander, if I can discuss the failure and complication. Well, usually zygomatic implants don't fail. As long as they are positioned correctly. So the zygoma bone is not resorbing. And one of the things that could happen is because we perforate the sinus, we can have some sinusitis problem, even though it is still from the literature, the problems of sinusitis are around 3-4% with zygomatic implants and without. So it's not really an issue. You might have some oral fistula that you have to cover by the damaging of the bone itself. One of the ways to do that is with buccal fat. You could have a resorption of tissue within time, but the fact that the implant is the color of the implant is not machined, and it's not threaded, and it's not surface treated, it's machined. Even if you have tissue resorption, the area is not infected and it is very easy to clean. And this is one of the advantages of this kind of surface finish and color versus other implants that have thread all the way toward to the crest. I hope I answered this question. I try not to give answers, clinical answers. I would leave this to the doctors. I'm trying only to give answers in terms of mechanical issues. I want to concentrate on that. Is it possible to give a warranty of, let's say, 5 years? This is George. Well,
yeah, I think. Sorry, I have to explain my my question, because I placed that earlier. We have usually in Germany the patient requires minimum 2 years warranty, but related to the resorption of the bone and so on, it may be possible that that the bone is resorbing a little bit stronger sometimes. And what is the maximum? Was the question really? Not is it possible to give 5 years warranty?
No, of course, it's possible. And as I said, the zygoma bone don't resorb. You might have some problems on the crest, but the zygoma bone don't resorb. And once the implant is positioned correctly, let's say, when I say correctly, I would say, going into this surgery, even for experienced surgeons, there are many surprises. And you've seen how complicated finding all those angles are. even your experience and you've done many, sometimes things don't go as expected. And we should all remember that zygomatic implants are actually the last chance for this patient, because we will not put a zygomatic implant if we can do anything else. So we don't want to fail. So if, let's say, if we did it freehand and the zygomatic implant was positioned correctly and the bone was, the zygomatic bone was correctly long enough and so on, this implant could hold many years. So they're much more than 5 years, okay? Unless,
thank you. Yeah,
unless there, as I said, there might be some complications in terms of sinus or whatever. But in terms of having the implant on the bone and integration with the bone, it will hold for many years. So one of the best things to do is to do this procedure guided, and then you know exactly where the implants are going to be, and you can guarantee with a lot of confidence that what you're going to do is going to be perfect. You have no surprises with guided surgery. We'll talk about this on Monday. I hope you join us. Let's say let me just open. I have a question from just a minute. I want to open Michael. Just a second. Participants, Michael Lees. I don't see Michael Lees. Okay, I don't see you. I don't know how to open. Okay, the question of Michael was, no, I lost the question. So how do we find the entry point? So we talked about that already, so I will not repeat myself. If the goal is for more big within the zygoma, perhaps 15 millimeter, but third portion of our implant is maximize circulation of the anterior side of the zygoma. Is it not necessary to get more than the question from anonymous attendee? Okay, if the goal is for more big within the zygoma, perhaps 50 millimeter, but the threaded portion of our implant is 12 millimeter and a half, how can we maximize also integration at the anterior side of the zygoma? Or is it not necessary to get more than 12.5 millimeters? Well, the zygoma implant that Norris has, the implant, the threaded section is 13 millimeters, but the implant is actually surface treated up to 60 millimeters. And 60 millimeters in the zygoma bone is more than enough. So I hope this answers your question. How close can they be? Great, Daniel Delors. How close can they be greater than 3 millimeters? Let me just open you, Daniel. Open the microphone and ask me, Daniel. I don't see you. Daniel. I don't see Daniel on my attendees. Maybe Daniel left. Okay. Eileen, is there any contraindications to immediate loading? Eileen? 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 Okay.
He's on mute, Rami.
Eileen is on mute?
Yes.
I'm trying to see how to open Eileen. Eileen? No, the microphone of Eileen is open. Eileen, do you hear me? Is there any contraindications for immediate loading and assessing primary stability? Thanks, Rami. Oh, she left. Okay. Well, it's usually when zygomatic implants are placed in the bone correctly, and we have let's say above, we can get to torques up to 80 Newton centimeters. Okay, so if you have, let's say, torque up it's around 30, 40, there is no problem for immediate loading. Usually, I've seldom seen zygomatic implants that we didn't load. As long as they're positioned correctly. If the implant is not stabilized, then either we don't load it, but if it's not stable, if it's not stabilized, it could be from two reasons. Okay, first of all, it could be that it is in the right, exactly the right position, but we used, let's say, a drilling protocol that we remove too much bone, so the immediate torque is not high enough. This could be one problem. But usually what happens is that if we have an implant that is moving, it's probably because it's not positioned in the right place, and it's not in the bone like we wanted it to be. So this has to be checked, and sometimes we need to re-drill. It's not always possible, because once we've already drilled, basically we remove the bone from the position we drill. Then when we drill again, so the implant actually has less bone, or it will not hold. But in this case, on the spot, you have to decide what to do. So there's not a good answer for that. Okay. Jasmine. Let me open Jasmine. You don't see you, Jasmine. Yeah, here you are. Jasmine? 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 Well, I don't see Jasmine. Okay. The question is, I only ever use the rough diamond. When would you ever use the medium or smooth groove burr? Well, when we started, we decided to make 3 courses of diamond: the coarse, the medium, and the fine. Usually, we use only the coarse. Even if we perforate the maxillary sinus wall and we approach the membrane, it wouldn't really damage the membrane. But in this case, you could use a finer grit of the diamond and switch to the fine. But the coarse one does the work very good. So you should just try and see. If it depends on the membrane, it depends on the case. But if you want to remove material, you want to do it with a coarse diamond drill. Gilbert Tremblay, how do you avoid the whiplash effect due to the length of zygoma implant? Let me open Gilbert. I want you to explain me what you mean. Gilbert, allowed to talk. Gilbert? Well, Gilbert is not answering.
Hello.
Hi.
Okay, hi, how are you doing?
Gilbert?
Yeah, that's me. Okay, so you're talking about guided surgery over here. And with guided surgery, the longer the implant is, the more the areas happen to be at the tip of the implant. So by having an implant so long in the zygoma area, how do you counter that whiplash effect, the fact that the tip will be more unstable in its position as if it was a smaller length implant?
Well, that's the trick of the zygoma. because the Zygomatic, the guided surgery that we have, gave the solution exactly to this question. And the way it's made, and I hope you'll be able to visit us and to hear the session on Monday. You'll see how it works. And basically we solved this problem. We know today with guided surgery to position implants all the length to the apex will be around 1 to 2 millimeters away from where it was supposed to be on 60 millimeter length implants, okay? And positioning them on the crest within 0.5 millimeters. So we can almost bring, we do actually, with the Zygomatic guidance process, we can prepare bring the multi-units to the position and the angulation correct that it is that you can put the restoration. And I hope to see you on Monday and you'll see the trick.
So Monday you can have a webinar on this here?
We have a webinar on Monday. You can apply to this webinar. If you go to our website, you can just apply to the webinar. It's on Monday, same time.
Is your guided system on production yet, or it's still under beta testing cases?
No, I've done 500 cases already.
Okay, so you're not on production yet?
Of course we are. We are in
production.
You
are? Oh, wonderful.
We've done over 500 cases, and in Israel, in Europe, in the United States, some very famous doctors in the United States used it and approved it, and it's a really good system, really good system. Today, it's considered the best system in the market in terms of.
Okay, so thank you. I'm looking forward for Monday.
With the Zygomatic, just give you another information, some more information. For instance, if you go to a quad zygoma with 2 pterygoids and let's say 2 laterals, you can finish the whole procedure from the minute you started cutting the flap until you've put the last multi-unit in the mouth within an hour. And
interesting.
We'll talk about it
so is your guided system also available for quad zygomas or just for single zygomas?
No, for quad zygoma, pterygoids, everything.
Okay.
Everything. And I will talk about this with a lot of. I will explain how it works on the next session.
Okay, so thank you.
Thank you. Michael Lees, when is the easy planning going to be available? It is. You mean the software? Soon. I'm answering Michael Lees. The question is, when is the easy planning going to be available? Well, it's available now, but we're going to have it in the market in terms of selling the software or some other ways be soon. But you will only be able to position implants and make the planning. The guides will be done by Norse Medical in Israel. Okay, another question. Sometimes, again, Michael Lee, sometimes the anterior implant is more than 60 millimeters. Could you manufacture longer implants? Well, I agree with you, but it is really, really in unique cases that you need more than 60 millimeters. And today we have in our catalog up to 60. Of course, we can do more, but in terms of FDA and regulation and so on, I don't think we'll do that for these extreme cases. And from what I found out, after planning many cases, that I didn't need more than 60 millimeters. So this is the answer for Michael Lees. Johnson James. Hello, Johnson. Let me just open Johnson James. Johnson? Johnson?
Hi, can you hear me?
Yeah.
Hi, how are you doing?
Great, how are you?
Doing good. I've been watching these guided protocols very closely, and one problem we face is the possible angulation of the multi-units. Now, with these protocols, you can also tell us this will be the angulation we need, right?
Are you talking about the guided surgery?
The guided surgery, yes, and the multi-units will be using after the implant placement.
Of course, the Zygomatic enables you to position the implant in the correct position, in the correct orientation, and to have the multi-unit angle exactly the way you want it so that you can take the restoration and put it directly on. That's the accuracy of the Zygomatic, if it's performed.
Zygomas, I can agree, but the pterygoids also, we get the right angulation, is it?
Of course. The pterygoids, every implant that's done with this in this procedure is exactly at the position and the orientation it should be. We'll talk about this on Monday.
Monday. Okay, fine. See you then.
Michael, in order to prevent recession, some authors have suggested to do style graft. Well, I prefer not to answer about grafting. As I said, I want to keep my answers on mechanical issues only. So forgive me, Michael. Jasmine, I love the system, but wonder if any tricks to make the drill a bit less aggressive. Ramzi Amin. Ramzi Amin, my dear friend, let me open.
Hey, Rami, how are you?
I'm great. How are you?
Hey, good. Nice to see you here. Thanks for being here.
Well,
I love your presentation.
Thank you. How are you?
I'm doing good. You know, as you know, I've done lots and lots of these, and I love the drill system. But just like maybe a few weeks ago, I was doing just a standard double zygoma, and the bone was very dense, and actually I got the drill stuck into the zygomatic process. By the time I finally got it to penetrate, it just got stuck in there. I was just wondering if there's any tricks or drilling speeds that you suggest. I'm usually drilling at about 1,000 RPM when I'm doing these. Well, yeah, even 800 probably is about average for me.
Well, you could, because you're drilling, with drill number one, you're starting with the dimension of 2 millimeters. You can go even higher in the speed. But I'm not sure that it's a matter of speed. Maybe we talk afterwards and explain to me exactly what happened. But anyway, you asked me, what you wrote here is to have the drills less aggressive. What we have done, the first drills we had for many years, they were a bit aggressive because we made them in such a way that they will go very, they will go in the bone without hitting the bone. Okay, and that means that means you need them to be more to have the bone that goes away from on the flutes of the drill will go easy out, and the cutting will be good. That's why they were a little bit aggressive. But now we changed the drills, and we have we changed the angles of the flutes of the drill. That now the drills are cutting nicely and not aggressively. As you said. So I don't know if you have the new drills or not, but let's talk afterwards and see what we can do.
Yeah, maybe. Yeah, maybe. But it's awesome. It works fantastic. And that was me that asked the question about do you ever use the medium grit or the smooth grit? Okay. That wasn't Jasmine's question, I think. But thank you for answering that as well.
What do you use? So what do you use?
You know, I pretty much just use the rough diamond altogether. I've never picked up the other two at all. Maybe once on accident, I think I picked up the medium groove burr, but the rougher one is certainly, it does the job very quickly.
Well, the medium and the rough are very close to one another. Yeah. So, as a matter of fact, in the new kit, I only left the fine and the coarse. I took the mid out because it's very close to the course.
Yeah, that makes sense. That's great.
I follow you with the Corona. What you're doing, very nice.
Yeah, that's tomorrow. So thank you for being here.
Okay. Are you going to be on Monday?
I think so. What time is it on Monday? Same time?
I think,
Okay.
I'm not sure.
I guess I'll find out my time zone, right?
Follow the advertisement.
Yeah.
Okay, I covered all the questions. Any more questions before we finish?
One question, Rami, I don't know if it was asked before, but the multi-units, there was a significant change from the 2020, from our previous multi-unit product line. And I just wanted to see if you can go over it and give us any kind of understanding about the changes and how this affects the prosthetic planning.
You mean the new catalog that we had? That's what you mean, the new heights that we have?
Exactly.
Okay, so there are two changes in the catalog for multi-units. First of all, we added more heights. I'll just open the catalog and try to show it to the camera because I don't have a slide for that right now. So let me just, yeah, I'm talking about this page, and you can see that there are more heights. And what another change in this catalog is that actually we defined the height of the multi-unit base versus the implant a little differently, and and they are positioned on like how do you say that? Screened by the height. But if you look at the catalog, you'll probably understand what I mean. We added height so that we have for 17 millimeters, we have multi-units going up to 5 millimeters above. For 30, we basically have for all the multi-units, they're going up to 5 millimeter height above the implant. So that means that you have 5 millimeter height of gingiva. You can use the multi-unit with one piece going up. For 52, what else we did? We took the VariConnect, which basically is like a multi-unit, but it has a threaded. It had a threaded. I don't know if you can see. It had a threaded section here. I don't know if you can see that. A threaded section here, like that. And on the threaded section, we put drill extender, basically platform extenders. So actually, we can lift up the platform straight up without having any side effects like that. So this is also a very interesting product. It is two-piece product, but there is no other technical solution for having a correct multi-unit for 50 to 60 degrees going up this much. And in this case, it's recommended to use this kind of solution. We'll probably very shortly come out to the market with some more literature explaining this, and they're working very nicely. Okay. Any more questions? Okay, so I want to thank you very much, and I hope I've given you a lot of information so that you can work with. I hope to see you on Monday, where we will speak about the guided surgery and the advantage in the guided surgery. And if you still have any questions after that, just send them by email to Norris Academy via our website, and we'll answer you. So thank you very much, and I will be closing this session. Thank you.